Okay, we did it. Hi. Oh man, that was fun. That song gets a little repetitive.
It's kind of energetic music.
Yeah, very energetic. Little. I mean, it's coffee and software, but that wasn't just coffee. There's something else there. Maybe 2 cups of coffee. Hi, Chris. Good to see you, man.
Oh, it's good to see you too. I'm starting to stress about my background.
Why? Oh.
It's like what's actually visible behind me.
Oh, don't you have the Mac filter effect thing? You can go up to the drop down thing in the top right,
Oh,
and there's
you
a
actually do a blur? Can I do a blur?
yeah. It's an effect now. It's part of the Mac. You go to the video effect. You know where it says "Do Not Disturb" and the Wi-Fi and all that in your MacBook Pro. The little
Wow, I didn't know about. Oh, wait, in the app, there's a blur. Okay.
no in the Mac. There you go. Yeah, it's blurry now.
Okay, cool. Now I'm hiding all my crap.
I just got back from a fairly good trip, and yeah, we're all tired. We're a little jet lagged, because again, right now it's, I don't know, what's the time? Time in Tokyo. And 6 a.m. So I confess, had this meeting been a couple hours earlier, my partner would have been asleep in the bed there. So talk about cleaning up, curating your background. I had to move the body.
You had to throw her out to the room.
Yeah, well, you don't throw. No. She's stronger than I am. That wouldn't go well at all. No. But I'd make a cup of coffee. I like, come on, follow me. I'm a whirl with emotions today. First of all, Maui's on fire. That's not good. Second of all, today my kid's going to her college orientation in the school she's going to, right, for university, and
wow.
So that started just as you and I got on the digital horn here today.
Wow, that's exciting. Big step.
Big step.
You feel all grown up now?
I should. Yeah, I don't know. Do you feel grown up? I don't feel grown up yet.
No. Yeah, it's complicated. In some ways, yes. In other ways, no.
Yeah. Like so people have taken to that word adulting, right? Like when they recognize they're doing a thing that was otherwise more mature than they would have otherwise been expected or capable of being,
Yeah.
And I kind of relate to that, but I guess I'm just secretly not willing to admit that I relate to that. So I don't know. I've probably tried to affect the word adulting, but
well, it's important to whatever your age to actually have fun, and maybe with adult, the word adult just sounds so serious, right?
That's what my parents were.
Like, yeah, we should talk about mortgage, our investments, how the kids, and all that sort of adulty stuff, as opposed to just, well, actually serious work, interesting technology, but just actually have fun as well.
True, which is why you're here, by the way. Thank you so much for joining me today. Who are you? You want to introduce yourself so I don't butcher it? I could just say you're.
Apparently, I'm a legendary cloud native.
True, very true. Fact.
Which actually we could have a whole discussion on each one of the words in that.
Yes. I can help with the word "the."
Yeah. So yeah, well, I'm Chris Richardson. Yeah, I've been building software for 1 million+ years. Notable things I've done, like I wrote the book Pojos in Action quite a long time ago. I created the original Cloud Foundry. I wrote the book Microservices Patterns. And I basically work with organizations around the world to kind of improve their architecture and improve their development processes.
Fruitful work, because there's always, and I mean always, more of it to be done.
Yeah.
So let's do a little let's do we'll work backwards. Start from the beginning. What why software instead of I don't know, whatever the alternative might have been. Why'd you get into it? I don't know. I always wonder why people like you ended up where you are, which is great for us. But what were the alternatives at the time? It had you
Oh yeah. Actually, what I'm trying to remember, did I ever think of any other alternatives?
Sure. I mean, before you knew of computers, what was your thinking? I'm going to be an astronaut. I don't know, something like that.
Yeah, I guess so. It was funny because it's sort of quite. I think I was young but I can't remember when exactly.
Right.
I mean, I was always kind of nerdy, into science and stuff.
Yeah.
And then at one point, I discovered a book on computers that my uncle had left lying around the house.
Mm-hmm.
And we're talking a lot. I mean, we're actually talking a long time ago. This was, I mean, gosh, it must have been maybe late 70s.
Okay. Whoa.
And I just became fascinated by this computer thing. And, it was really funny. I didn't even own one much later in life, but there were various points in my life. I mean, this must have been when I was 15 or something like that. I would go to the local computer store where they had a Commodore PET. You remember that brand?
No. I mean, I know Commodore certainly, but the PET, which was the...
Yeah, gosh, was that a 6502 8-bit processor, ridiculously slow clock speed? That storage mechanism was a cassette tape drive.
Right. All a bit better than a punch card.
Yeah, I managed to miss out on the punch card thing.
Yeah.
But yeah, cassette tape drive was pretty radical at one point.
Yeah.
Anyway, so somehow I just got kind of hooked on computers, and here I am a lifetime later.
It's worked out okay. I mean, yeah, okay.
It's not bad. Yeah. I mean, it's funny. It's hard to imagine doing anything else, to be honest. Well,
Yeah. This is the thing, right? This is one thing I don't think is, if you get to the point where you're having fun with software, and I'm not saying that's for everybody, but if you manage to get to that point, it is very addictive. It is very satisfying to succeed. And not that I would know, but I've been told it's very addictive to succeed at software. To win. To build something and see it work. There's a chemical reaction there that is.
Even when I've had jobs that sucked, right? There are various points in my career where I've had a job that was just sucky kind of work environment, culture.
Was that the people? It's never the software; it's the people around it, right?
Yeah. I mean, it's primarily the culture and people, right? They're what make the job suck. But I mean, I've always loved the technology part of it, but whatever was going on in that company at that time was most unsatisfying. But throughout that, I've always enjoyed tech. And actually, in a way, some of the times when it's really sucked the most is when you feel like you're not accomplishing anything.
Story of my life.
No, come on. But it's funny. There's actually a book, which might have been an article, called The Productivity Principle.
Mm-hmm.
And it just basically says that one of the key factors that makes a job enjoyable is actually feeling like at the end of each day, feeling like you've accomplished something.
Yeah.
And there have been times when, I mean, that's been some aspects of jobs that have sort of been unsatisfying, have lacked the sense of accomplishment.
You ever read the book Drive by Daniel H. Pink?
No, I know of it, but
it talks about why people do what they do, and it talks about drive 1.0 is like perpetuation of the species, like eat and other more carnal instincts. Okay, that's drive 1.0. Drive 2.0 is carrot and stick. Like you incentivize somebody by reducing tax or giving away, making it financially advantageous for people to do a thing, and you discourage it by making it financially disadvantageous for somebody to do a thing. So a lot of states will tax alcohol, vices, whatever, because they want to. That's the stick. But they want to make it easier. They want to encourage families, so they make it so that you get a discount on your tax for that if you're married and have a family. But that doesn't explain open source, right? Those two drive engines don't explain like why people do things for free, or out of the goodness of their heart. It just doesn't work in that world, right? A lot of what we do, and the example they bring up is like Wikipedia. If you had asked a classic economist in the 1990s and said, hey, what is going to be the best encyclopedia product? Microsoft Encarta, paid by Microsoft with paying a fleet of people working eight hours a day, the best of the best, being paid gobs of money, or this ragtag amateur outfit with like 8 people working entirely on the basis of donations by volunteers all around the world, doing it for free and for clout. Which one's going to produce the better product? And the classic economist would have certainly said Encarta, right? That would be the But of course it isn't. And same thing for Firefox. Why did that take off?
It is actually funny. I mean, that you bring up open source,
right?
Because on the one hand, you're right. I mean, it is people doing it for the love of it, basically, and for the most part. But it is this. I part of me does think that it's overly worshipped, and I really wish there was actually a way to enable open source developers to actually properly profit from the companies that make money, in some cases, huge amounts of money from open source, right? Like it's very hard to do open source as a viable business model, right?
We should touch on that in a second, but
that's a whole other thing.
But the book, it concludes that basically you get the reason people do this, the reason Drive 3.0, going back to what you're talking about being satisfied with what you have done, a reason that people do these things, and this goes to the discussion on open source, because you don't need to be in open source to get these same results if you know what you're looking for, which is basically time. You have control over what you're doing, how you're doing it, and when you're doing it, right? And basically that whole sense of being invested in something, it promotes that sense of being invested in something if you can control how you're doing it, what you're doing, and when and how. And the example they gave in the book was Zappos, the customer service for Zappos, the shoe e-tailer that got absorbed by Amazon some years ago. Yeah, they're selling shoes on the internet, very intimate affair, right? Like I want to walk around in shoes. I need to be able to feel that. It's not something I want to do sight unseen on a web page. And yet people did, and that was exactly their proposition. And the way they made that viable was by saying, hey, look, if you contact our customer service, we're not going to have some drone reading a script trying to force you to keep the shoes that you don't want, trying to saddle you with charges and all that. Instead, we're going to make it so that if you buy a pair of shoes, you get them delivered and you don't like them, you can send them back pain-free. You can talk to the representative immediately. There's no basically they had to make the customer service experience impeccable. It had to be so good that it felt painless. And the only way that could happen is if you made the people working in the customer service department partners in the result, in the project, right? And so what they did was they said, okay, we're not going to force people to go to the office. This is just a phone call. They can do it from home. We're going to let them do whatever they want. It was like the original gig economy, right? They can get, if they have kids they need to take to school or pick up from school, they don't have to be on, do whatever you want, sign in when you want, take calls. You can do it when you want, and you can solve the problem any way you want. Like there's no preferred outcome here. If you talk to them and they want to talk about sports for 20 minutes, be our guest, as long as they feel like they came away from the conversation happy that they did so, right? And so people became, first of all, call centers, the retention rate went through the roof. People stayed in the call centers because they didn't feel like they were being abused. They didn't feel like because nobody wants to work at a job where you're constantly being you're dealing with unhappy customers all day. It's demoralizing.
Yeah.
So this fixed all those issues. It gave people this feeling of I am part of the solution, as opposed to just a cog in the machine. I'm invested in the outcome, and I want the result. And so again, if you know that, and if you think about what software gives you, GitHub open source software gives you, sure, it gives you that if it's done right. But similarly, you could work in open source and not get that, and then also you could work in proprietary software and have that, right? It's not exclusive either.
Yeah.
Right?
It is. I mean, it is. You do want work environments that empower people to be human, right? Whereas, like customer service is a great example, right? Where sometimes you're communicating with a customer service person, and I honestly don't know whether they're a bot.
Oh, it's so sad. They don't want to do that.
Like, oh, I'm sorry that you're having this problem. I understand how difficult that might be for you.
Right.
With completely robotic scripted response. And I'm sure it's a human, but they are basically, their job is actually kind of dehumanize them and just turn them into corporate blurb bots, right? But that's that, and there's a lot of work environments that do that.
Mm-hmm. Yeah, absolutely. I wanted to I want to go touch on the thing you were talking about earlier, which is making it financially rewarding to work in software. But I feel like we're kind of it's no great time to ask this. What would you recommend, now that we're talking about the sort of beginning of your journey, what would you recommend for others who are looking to break in, to get into software? Like what should they, in 2023 world, obviously, your experiences are useful, but relative to today, knowing what you know, what would you say to young people looking to break, or any people looking to break into the industry?
Plastics, my boy. Oh no, sorry, wrong song. No, I mean, like, what do I think? I mean, there's a few sort of philosophical ideas, right? I mean, I feel like people should be curious, right? They should be humble. They should recognize that it depends. Like, a key thing in software is that it really does depend on any design decision is not sort of necessarily black or white, right? And then, related to that is the concept of no silver bullets. And just to, especially to be curious and constantly learn.
Right.
And then also recognize that, you're in I wrote about this, I think yesterday, right? I mean, we're sort of, in the software field, we all think it's new, like it's all a super young field. I mean, in a way it is relative to some ancient disciplines, right? But, there are software concepts dating back 50 plus years, right? Concepts of modularity, that's like 19 PaaS, 1972, 73, right. Mythical Man Month, 1975, right? Which is all about teams. Coupling cohesion, right? That's like another 70s concept.
Yeah. So 50 plus years for all the good stuff. I mean,
and what's even more than that, like so much of the fundamentals were actually sort of, in a sense, figured out 50 years ago.
Right.
Yeah. And yet, like so many of the challenges that we face in the industry, or some people, organizations face, is that they then go and ignore all of those fundamentals, right? Like their whole way of structuring teams probably violates the Mythical Man Month, right? They build tightly coupled systems which kills productivity.
Yeah. So the Mythical Man Month, of course, is the book that famously introduced the notion that, the nonsensical sort of notion that, if you add more people to the project, you'll be able to divide or reduce the time it takes to develop the software. And then, of course, in the book, they say that's doesn't actually hold up to water. You can't, if it takes one woman to 9 months to have a baby, it's not going to take 3 women 3 months to have a baby, right? It doesn't work like that. Some things take 9 months, and that's the book had that analogy about a pregnancy,
Well, yeah, I mean, well, I think one of the phrases is, right, adding extra people to an already late project makes it even later, right? Because, you're dominated by it just increases the cost of communication and coordination between the teams, right?
Right. And we'd see Conway talk about that also in the 70s, the cost of communication.
Oh, yeah. I mean, that's another sort of ancient thing, right? Conway's law, which once again is kind of ignored by people, right?
Yeah.
And yeah, there was some more interesting research, which was like some organization found that a team of 5 people could get more or less the same amount of work done as a team of 20, possibly with higher quality.
Is this, and this, I think, so when we talk about, maybe we're getting ahead of ourselves, but is this all precursor to sort of the rediscovery of, 2 pizza box teams and all this kind of stuff in the last 10, 15 odd years?
Well, I think it's all, I mean, like, yeah, the 2 pizza teams, though, of course, that depends on how big your pizza is, right?
Yeah, sure. Or how big your appetite is. But yes, anyway.
Yeah.
Like Bill Murray
said. Places where, gosh, you order a large pizza, that's just 2 people.
Yeah.
America, a large.
Hey.
Well, yeah, I mean, that's sort of restatement of, because it's all about people, right? And fundamentally, people don't change. Oh, go on.
I just wanted to. There was a parody Bill Murray account, and one of my favorite tweets ever, which is any pizza can be a personal pan pizza if you believe in yourself, right? Yeah, it's true. It's my life.
Yeah.
This is the way I live my life now, Yeah. Anyway.
Well, I think, like one of the reasons these principles are so long lasting is that it's not about technology, it's about people.
Yeah.
Right? Software is always built by people, and they
chat GPT in the chat.
Yeah, we should get to that.
Sorry.
No, so yeah, people need to communicate, right? And so if you have a large team, it's dominated by communication, right? And I mean, the trick is, obviously, there is software that needs to be developed by more than 5 people, or whatever, team topologies like 5 to 9 people. But the trick is to actually split it up into these loosely coupled teams that rarely need to coordinate their work.
Right. They have a surface area that's well understood and documented, the API or whatever. And then
exactly.
The example they were giving in the Mythical Mammoth actually was an operating system, which is one of those things where I suppose if you're building a monolith, like Linux is not a microkernel, it's a monolithic kernel, right? It's one big morass of code, very, very sort of tightly linked to each other. Is it possible to, are there some endeavors, some projects for which this accepted wisdom is not true? Can I build? Well, I guess I just gave the answer. The microkernel would suggest I could have small, loosely coupled teams, right? But are there some things for which that's not true, where you do need to just have a lot of people with a lot of overhead focusing on one thing, conceivably?
Well, conceivably.
Don't know.
But I guess I sort of feel that you should always be able to split things up into into loosely coupled modules.
Yep, that's true. Even assembly has code pages and stuff. It should be possible to extricate these things from each other. Okay, so
yeah.
The team structure, the 5. So you mentioned 5, and of course that gets us to the rule of 5, 50, and 500, right? The amount of things we can keep I think it's about mental bandwidth, right? 5 is how many people you can keep, people whose status you can keep in your head.
Yeah, well, it was like what's it, Dunbar's number?
Is that what it is? Yeah.
Yeah.
Just a very interesting. There's a lot of things to back up this idea of 5 people. A small pizza box team, 5 people, Dunbar's number. It just seems to be
Apologies, to be fair, goes up to like 5 to 9 people, right? And then you could have analogies with, well, actually, I guess soccer teams, even though there's a small, relatively small number of people on the field, you could actually have more back in wherever they hang out when they're not on the sidelines.
Right.
But it's sort of smallish, right?
Yeah, certainly. I wonder if that is it true for everything? Like, I guess a restaurant, if you had like 20 people working in a restaurant, that would feel chaotic, or at least certainly. I don't know. I'm just trying to figure out where that number.
Well, there's sort of, I mean, I feel maybe there's a difference between like very rigid work environments, right? Like, I mean, you could say like working like a factory. I guess there are factories that have thousands of people, right? But it's all, you know, they're sort of implementing different steps of a very well thought out process, right?
And the lanes are clear.
What's that?
The lanes in which they have to which they have to do are understood.
But software is you know, despite efforts to the contrary, is not a factory.
Right.
It is a design process, which is all about, I mean, it's all very conceptual, and it's a learning exercise, and it's a communication exercise. And so I think it does, you know, there are these constraints.
Yeah. Is learning, how heavily does the ability to learn from what you're doing impact or inform the way you build software? Like, to what extent is being a learning organization an end goal?
Oh, yeah. I mean, well, you think about, I mean, that kind of like goes back to sort of software development culture, right?
Right.
The idea is that you very much need to be a learning organization, right? Because I mean, presumably, if you're writing some software, you're actually doing something novel, right?
Well, speak for yourself.
Well,
I feel very attacked. How dare you? Anyway, carry on.
Well, why do you just keep doing the same thing over and over again?
Ow! I'll be over here if you need me.
But you know, okay, if you're a enterprise developer, right?
Yeah.
I mean, presumably the software that you're building actually is distinctive, right?
Yeah.
Because if it's not distinctive, why didn't you just buy it in a generic sense from buy someone's product or SaaS service, right?
Yeah.
You wouldn't be repeatedly reinventing the wheel, even though I actually suspect a whole lot of that goes on, right?
Yeah.
But I mean, you know
it does.
What's that?
Oh, we know it does. Look at Stack Overflow. How many people are asking the same question?
But you should be building novel things, right? And with novelty, I mean, by definition, you do not know what you're doing, right? You kind of think you do, you have a rough idea, but along the way, you discover what's really happening, and you know, and say mistakes get made, and you should be constantly learning from those mistakes, right? You know, so if something goes, I mean, so this is very clear when you have production outages, right? You have a post-mortem, blame-free, where you actually have an honest discussion about what went wrong, right? And how you can learn from that and improve as an organization.
Yeah.
I mean, you know, and that is extremely healthy. I mean, sadly, there are companies where that doesn't happen, right? Something goes wrong, you find someone to blame, right? Scapegoat, maybe, oh yes, let's just blame the consultant, the external organization, and then move on, learn nothing from the mistake, and then just carry on, right?
Right.
And you know, which is bizarre, but that, you know, I mean, there are companies which have that culture, and means you don't get better as an organization.
And of course, we're bound to those companies, like all that seem to forget the lessons of history, are bound to repeat those same mistakes, right? You just mentioned learning. We talked about learning here, and I think learning is really important, especially in a small team, because you don't want to be, there's the bus factor, right? And so we have a great question here. Raja asks, what are some strategies we can use to reduce the truck bus factor in the team, right? Which is the dependency on 1 or 2 people, for example.
Well, I mean, I think, the thing about kind of like collective as in team is team ownership on the of code, right?
Mm-hmm.
I mean, I think sometimes, I think I've encountered this where, some organizations, they seem to have a service per developer. So you have the whatever team, and then on that team, there's Tom has implemented a microservice, Mary has implemented a microservice, and so on and so forth, right?
Right.
And there's not really a team, right? It's like a collection of teams of one who happen to have the same daily stand-up, right?
Right.
Whereas, if you actually practice code ownership, collect code ownership there, each team owns their code base and people work on it interchangeably, then I think that's a good way of just kind of, I think that's a much better way of working.
You've got so this brings that what you just said about having these really small services, that reminds me of our old friend, Fred George, who talks about having like literally micro services, right? Like services so small that you could just throw them away if you wanted to redo it, right? It reduces the surface area, and therefore it makes it easier to evolve, and you don't have to write tests because you can just see what everything's doing in plain sight. And I always thought that was kind of an interesting take. How do you describe, like, we've talked about teams, and when I think of microservices, I think of teams, not line size. But is there something from that angle? How would you describe what is the bound, the extent of a service at which it no longer is a microservice,
Yeah. Well, yeah, I to be honest, I mean, I think it all depends upon your context, which includes what kind of application you're building it and who's building it. Right.
Yeah.
But I lean very much in the direction of kind of having relatively coarse-grained services. Like if you think about one of the key goals of microservices is team autonomy. So team is able to develop, build, test, deploy, scale their service independently of what everyone else is doing. Then you can achieve that with just one service for the team.
Yeah.
Right.
Makes sense.
And so, and then what's more, right, is the more services you have, the more complex your system is, and you're starting to get into issues around performance, data consistency, runtime coupling.
Yeah.
Plus, I mean, but then on top of that, I think a really hard thing to do is to define your service boundaries, because you have to design them in a way that you minimize design time coupling, right? Like the likelihood of two services having to change in lockstep. So, because it's hard, I would argue the fewer the better.
Right. Yeah.
And and by the way, what I've sort of talked about is I mean there are all these criteria or forces that you need to take into account when designing a microservice architecture, and I call those the dark energy and dark matter forces, right? Dark energy, because I did it because it sounded cool.
It does sound, and it's galactic brain,
Yeah, and it's metaphors from astrophysics, right?
Yeah.
So, dark energy is an anti-gravity that is causing the expansion of the universe to accelerate. Because you'd sort of expect the universe to and gradually slow down, right?
Yeah, the more mass it's moving, you think it would.
Apparently, what was it, 13 billion years ago, the universe was in a hot, dense state. Oh, wait, that's something else. But then, so the Big Bang happened, was it 13 million years ago? And then it slowed down, but then apparently 7 billion years ago, it started accelerating.
That's so cool.
This notion of dark energy pushing matter apart, right?
Yeah.
Which is like, I don't know, it's partially, I think some of these astrophysicists just make stuff up, actually.
Please, do not, they're having fun. Again, go back to
it's cool. And then, so that's dark energy, anti-gravity that's pushing, in the case of a microservice architecture, your subdomains or your bounded contexts apart into separate services, so you can have team autonomy, a fast deployment pipeline, and things like that, right?
So okay.
Oh, go on.
Oh, no, please.
Oh, then there's dark matter, which is yet another invisible thing that these astrophysicists have created, which is this matter that you can't see, but it appears to have a gravitational effect. It's kind of like
externalities, like people.
This is like Kepler's third law, which I can barely remember, but apparently the speed at which, say, a planet goes around the sun is a function of the mass of the two bodies and I guess the distance, right? And what they've observed is stars rotating around galaxies in a way that there is more mass than can be visibly observed. Hence, we have dark matter to make up the difference. Right.
And they notice that only because of the light bends in certain ways, things like that.
It's like the orbital velocity is something like it's faster. I think it's faster than it should be.
Right.
Quickly go to Wikipedia and look up Kepler's third. I think it's Kepler's third law.
So cool.
Yeah. So it's like there's more mass in the center of these galaxies than can be observed. And that's like there's this attractive force acting upon your subdomains that actually resists putting them in separate services. Like the fact that partially it's due to the fact that the network is costly, right?
Yeah.
So you can get into efficiency issues. Then there's also the fact that if you have an operation that spans services, it can't be ACID. It needs to be eventually consistent, which is a far more complex programming model. So so you've got 5 forces that are pushing your subdomains apart, and then you have 5 forces that are making you want to put them in a monolith.
Which gets us rather perfectly to a question that our friend Thomas asked some minutes ago. How many teams could work on a monolith? So obviously in the Spring team now we have a project called Spring Monoliths, but it's basically a well-factored modular monolith, right? Thoughts on any of this?
I don't have a good number, right? Other than 42, I guess.
Right, yeah. Okay.
No. So one way to think about it is, a good development practice is continuous delivery,
mm-hmm.
right? Which is where, every developer commits to trunk every day, right? And that commit flows through your deployment pipeline, which builds tests and then ideally pushes it into production.
Mm-hmm. So that's I love continuous delivery. That's the original continuous delivery book. That's the idea of committing to trunk-based development, right? And
and frequently. as
Right.
well, right?
Daily integrations, no outstanding branches, no long-lived branches.
Yeah. So if you believe in continuous integration, you must integrate continuously, not right.
And I guess there are some people that would say that, like, so if you commit into trunk all the time, then the question is, okay, well, what if it's not ready? And then it talks about there's this discussion around feature flags and all that. A lot of people say, well, isn't there some middle ground? Can't I use a branch and then like integrate every other day, wherever? And it's I don't know. Some people could say you can do continuous delivery without trunk-based development, and like they're not. Get flow, for example, is a very common practice. I don't think these people would describe themselves as waterfall adherents, right? Like they think of themselves as being continuously integrated.
I mean, I mean, one shouldn't be completely dogmatic, but there is this notion that you have a stream of small changes flowing from developer laptop into production, right?
Yeah.
So like one really interesting issue there, I would argue, is what's the maximum throughput of your deployment pipeline, right?
You mean how many times can I go from 0 to finished per day?
Yes.
Okay.
Right.
Okay.
And like, maybe the math is a bit more complicated than this, but like, let's imagine that your build takes 15 minutes, right? So let's assume an 8-hour workday.
So
right,
24, 30.
So that's 32.
Yeah.
Right. Which sort of assumes that they don't all arrive at once, right?
Yeah.
But so just some basic sort of modeling there suggests that eventually the rate of commits will actually exceed the capacity of your deployment pipeline, no matter how much technology you throw at the deployment pipeline to scale it, right? Parallelize, there's build caching, so on and so forth, right?
Yeah.
I mean, heck, your monolith can get so big that it actually takes a long time. Just starting it up can take a long time, right?
And that should definitely be a metric you consider when you think about your total time to production. It's just actual warm up stage.
So like one, so the question is how many teams can work on a monolith? That then does get back to this whole. I mean, one of the key things is, what is the limiting factor of your deployment pipeline?
Oh, wow. Because if you're doing if you have to make a change and you don't get to see it delivered to production pretty quick, like until tomorrow morning, you kick it off at 4:50 p.m. It's effectively, you're not going to see it until tomorrow morning. And so you've lost one of those chances to gain insight.
Yeah. Now, of course, one workaround to this problem is to commit changes less often, right? Yeah. But then, then that gets into then you're basically batching changes, and big chunks of changes are then going into production,
which is dangerous because now you've got more risk in one batch. Well, I mean, the continuous delivery book talks about the very sensical. What's the opposite of nonsensical? The very sensible.
Yeah, sensible.
Yeah. It talks about the very sensible idea that if you want to de-risk the process of deploying software, you just do it more often and do it more quickly, so that if you make a mistake, you can just back out of it, press on very, very quickly. Opposed to, like, I have these 6-month, I'm using air quotes here for the people on the podcast, 6-month air quote sprints, a 6-week sprint. That's not a sprint, in these large organizations, they deploy gathered around in the war room on a Friday night, that the mythical, the Phoenix Project style.
Exactly.
That's because if there's a mistake, it's going to be another few months before you get a chance to undo it or roll it back. And
just as a reminder, while we've been talking, right, Amazon, say, have been deploying changes, I don't know, is it every 0.6 seconds?
Right.
Something, I gather some change, right? And you know, and it's like, well, if you want to compete, you know, and to me, like, I feel like a lot of companies are at risk because some fast moving competitor could actually outdo them, right, by being able to deliver software much more rapidly, frequently, and reliably. And then the other thing, which is like, I feel like one inherent limitation of the monolith, right, is it's using the same technology stack.
Yeah.
Right. And so when you want to upgrade some dependency or your language runtime, right, you have to make that change to your entire code base.
Oof. Yeah.
Right. And fingers crossed, hopefully it's just a matter of incrementing using the new version and just rebuilding, right? But then sometimes there are changes that you have to make, right? Yeah. And so, you know, the larger your monolith gets, the bigger the presumably the more valuable it becomes, but the more entrenched your particular technology choices become, right?
Right. But what if you have 20 microservices and they're all using Spring Boot? Now you've got this problem divided across. You still have to upgrade all of them.
Yeah.
But it's just worse.
It's an interesting thing. But I can do it one at a time, right? So rather than one big upgrade project, I can do it one at a time, which arguably is easier to schedule. And maybe it's broken down the problem because maybe different services use different parts of, say, the Spring framework. And so some of them are easier to upgrade than others. Right. And then, or you want to upgrade to a new version of Java, right? You know, then I think we all know about there's applications that are stuck on some ancient version, right? Because the idea of upgrading is so overwhelming, right? And, you know, plus, I mean, the one funny thing is Java's been remarkably successful, right, at sort of longevity, right? But you think about all these ancient enterprise applications that were built with ancient technologies.
Yeah.
And companies have massive problems as a result, right?
I mean,
so like, you know, there's various metaphors for software. And one of them, remember there's that idea of a boat and you replace bits of the boat one plank at a time.
Oh, the philosophical question. What was his name?
Is it still the same boat?
Yeah.
Or the other one, which I like, and I actually talked about a lot when I first started talking about microservices, but I haven't talked about it in a few years, is you think about the human body. And I mean, components of your body undergo replacement all the time, right? And yet we still remain ourselves. Well, mostly anyway.
Yeah.
So, you know, and I think software should be like that. I mean, I feel like we build applications that can live a very long time, and we ought to be able to incrementally upgrade parts of them. There was a comment just flashed up that looked really interesting.
Yeah, well, there's been a few here. First, we have a modular monolith with around 70 modules, refactored a couple of years ago. It's a 20-year-old app with 15,000 plus tests, and it takes 30 minutes to build with parallel test execution. They have plans to split the app in the future. I don't think it's a question so much as it's just a checking in, and it's really good. And then another question asks, and I like this one, what's a quote-unquote large monolith to both of you mean? What size are we talking about? Which gets us back to, I think the constraint is not lines of code, it's how long it takes to get feedback on that, right? And make change, affect change. Which is a constraint. pipeline as much as anything.
I mean, I wish there was an easy answer to this large question of like, how large is large, right?
Right.
Like it sort of goes back to how many teams can work on a monolith, right? Or monolith. And it's like, I don't know, but maybe it would be good to actually have a survey, which is like, this is how long it takes our app to build, right? And just gather a whole bunch of statistics around that.
Oh, that's a great idea. Twitter.
Yeah. You know, it's funny, in my brain, I got a whole bunch of research questions like that. Because, so part of it is maybe the other way of looking at it is, okay, you're responsible for an application and it's growing, right? By the way, that's like an ancient law of software development, Lehman's laws, which I just wrote about yesterday.
Yeah.
Like one of the Lehman's laws of software evolution, which basically says software, in order to be successful, applications constantly have to change.
Right.
Which is, you know, and that was from 1974. And they also grow in complexity, and you really have to manage that complexity. But so maybe a good way to think about it is, you know, you're an architect of an application. How do you know when you're starting to sort of let's say it's a monolith, how do you know when you're starting to outgrow your monolith, right? Because I would argue that is, I mean, I think that's really the essence of this question, right? And so part of that is, so let's assuming that you're doing continuous delivery, and all of the other good parts of DevOps as defined by the DevOps handbook, right? So your slow development process is not masking any problems with your actual underlying architecture, right?
Right.
Then, you know, so you want to be gathering metrics around things like deployment pipe or lead time, like how fast does it take to for your deployment pipeline to execute, you know, how many commits per day are you doing, right? Yeah. Also, how reliable are those how many deployments per day are you doing, and how reliable those deployments are doing, and just monitor that and make sure that those metrics are healthy. And then when they're not, start fixing, fixing them in some way.
I always say this: architecture is what we do given constraints, and you know, your build time is as valid a constraint as anything. If you move to microservices because of build time, that's not wrong. That's a reason, you know.
Well, it is all about speed, fast feedback, right? And which making it sound like it's about build time sort of trivializes it, because I think there's more to fast build time than simply having a fast build, right? But you know, while, you know, end users want a system that's usable, hopefully us developers want a system that is developable, right?
Yeah.
And part of that, I think, is fast feedback.
Yeah, absolutely.
So you want to have in place like an actual architecture group or person or role or whatever. So rather than architects being people who just work on big features, you want to have architects who do architecture and monitoring all of the sort of the vital signs of your application, both runtime and development time, and then have the time available to act on it as appropriate.
Is that sort of work out of band work? Like, do you need to involve everybody for that, or is there some things that an architect can or should be able to affect by themselves? You know, without too much disruption.
Well, someone or some group, right, someone needs to be responsible for architecture.
Sure.
Right. In a meaningful sense of the word.
Yeah.
So that's definitely part of it. And then, to be honest, the other really interesting part, which is sort of like, how easy, I mean, the interesting one is like how time consuming is it to keep the dependencies of your code base up to date?
Oh, yeah.
It's like both say because like one of the other goals of architecture is that your technology stack should be current, or sort of some book I read said it, the importance of a technology in your organization should mirror the importance of that technology in the marketplace, right? Which sort of means that you don't want to be using things that are necessarily too new, but you shouldn't be using them that are too old, right?
Right.
And I think a lot of organizations, I mean, it's keeping things current. I think it's a problem.
Yeah. Oh, for sure. I mean, we had John Schneider. He created Micrometer, and now he works on Open Rewrite. And the core conceit of that amazing project is just to help you refactor your code bases in an automated way. It'll upgrade dependencies, upgrade your code to move to Spring Boot 3, for example, from 2.7 or 2.x. Upgrade Hibernate for all of its various iterations. It's just a programmatic way to interrogate a code base and then apply refactors or refactors.
Yeah, I mean, maybe if you have a massive code base, you can open rewrite all of your problems away. But I suspect that the larger the code base and the diversity of its dependencies, the larger the task. And I think that to me is another compelling argument for trying to keep your app, keep the individual sort of applications smallish, right?
Yeah.
I don't know what smallish is. Like, I don't know what large is either, but having it broken up into these manageable pieces.
Yeah.
And you could, I mean, which I would call them services, but you can, they're just programs that you can build fast, and also you can upgrade fast as well.
In response to feedback, one hopes. This is a tortured segue, but it's all I got. Microservices typically run in the cloud. Why did you build Cloud Foundry? So let's go back a little bit, okay? Let's go back to you. We established you were a child, and then suddenly we're talking about architecture.
I was a child, yes.
I don't know. And then at some point you created this thing called Cloud Foundry. Like you joined. What was that journey about? Like,
actually, this is a funny story, right?
Yeah.
So back in 2006, I still do, but I haven't done anything. I run the local Java users group, right?
Yeah.
And we had 1 month, we had a speaker, you might know, Patrick Chanizon from Google, come talk about their APIs, right?
Yeah.
Check out, I think. Which, by the way, was the first time I went to a Korean restaurant in my life, and that started my love affair with Korean food. And then the next month, we had one of the evangelists from Amazon come visit, right? And remember, this was October 2006, I think. Okay. Yeah. And remember Amazon, they were a bookseller. So we thought they'd come talk about APIs for books, buying books, right? Kind of analogous to Google Checkout or something like that.
Yeah.
But instead, the guy talked about EC2, S3, SQS, which just blew my mind, right? Wow, you mean you can provision 20 servers and only pay 10 cents an hour? Well, or pay, provision them instantly or relatively instantly and pay 10 cents per hour per server. I mean, that just blew my mind, right? Because I was so used to traditional environments where it's really hard to get resources. And then I ended up creating this open source project called Cloud Tools, that would basically take a Java WAR file and provision the infrastructure. Remember, this was bare bones EC2, so there was nothing like that, right? But it was like, I think it would spin up Apache, Tomcat, MySQL, and do load balancing and actually auto scale it. That was with Cloud Foundry, but Cloud Tools just let you spin up, just type in a command and provision a bunch of EC2 stuff and configure them, right?
Right.
And then that eventually evolved into Cloud Foundry. And that was sort of that was triggered by the 2008 financial crash.
Yeah.
Because all the consulting business evaporated. And so I was I was running zero revenue consulting company, and I thought it would be better to be a zero revenue startup as well.
Right.
Sounds better. Yeah. So me and my friend, colleague Dimitri Volk, we pivoted from being consultants to actually building Cloud Foundry.
So, and Cloud Foundry was, like you said, a great way. And I remember the news of Cloud Foundry kind of hit the Spring community quickly because people were like naturally interested in it. It was a way to run Java apps, Spring apps of the day, you know, in Tomcat, right? It was naturally. And I remember it's not like people weren't already deploying Java Spring apps into Amazon before, but this just seemed like such a turnkey way to go quickly to production, right?
Yeah, and this was very much back in the early days, and like one of the success stories was there was a digital agency that was running Super Bowl ads whose URL, I guess, redirected to a website that was running implemented by a Java app that was provisioned by Cloud Tools and then Cloud Foundry, and also in the run up. Anyway, they would run ads, and then that triggered more visits, and so they'd scale up, and then when they weren't running ads, it would scale down, and it was all about beer and something. And it was like an example of being able to scale up and down in the cloud, and that was like an early success story.
That's awesome. And so this is, I remember, I mean, it really resonated with a lot of people. It was very successful, and so it wasn't very surprising at all when not too long. I don't know how long Cloud Foundry was out in the name, under the name Cloud Foundry, but it felt like it was a year at most or whatever, from my memory. And then suddenly Spring Source acquired you, and
yeah.
And
it was kind of like I learned about EC2 in 06, got access to it in 07, started building Cloud Foundry in the summer of 08, or maybe a little bit, but focused on Cloud Foundry in the summer of 08, and then acquired like basically a year later.
Yeah, and then acquired again by VMware a year after that. It feels like.
Yeah.
So that was a fun ride. So that was around 2009, and then I joined 2010, and then you and I got to work together. That was fun for me.
Fun for me too.
Well, it was fun for me because I got to work with you. It was fun for you because you got to work with Indian food.
Well, I enjoyed traveling around the world, specifically India, with you.
Oh, it was so much fun. And with Patrick, who you talked about a minute ago. Yeah.
I love going to India and eating nothing but Indian food. Straight. Three meals a day for 2 weeks. I was in heaven.
And that was just one trip. We did many of those trips per year. It was, oh my goodness. It was great. And then you kind of, during that time, you're already doing a lot of the prophetic work around microservices and talking about the themes that we've kind of tread in this very discussion. But again, 12 years ago, 13 years ago, you were already talking about this. A year earlier, even still, obviously.
I first gave a talk. I first actually gave a talk about microservices, even though they weren't called that, in 2012. actually, which was in Kiev, of all
Yeah.
places.
Oh, the spring day or whatever it was called.
Yeah.
Cloud Foundry Day.
Yeah. Yeah. And it just, and it was just, I give a talk about this. It was it was interesting for me because Cloud Foundry that I built was a monolith, and there were operational issues.
Right.
And then I read this book that said, well, you can break up your monolith into multiple pieces, and which was like kind of obvious to say that, but at the time it was like, wow, that's a really good idea. And it would have solved many of the issues that we had with Cloud Foundry. Interestingly, even though we were a small team, it was actually two people, complex application with sort of very diverse chunks of functionality, which would have been better off deployed as services. Right. So that's sort of why the concept of functional decomposition, aka microservices, resonated with me.
Right.
And then I started talking about it in the context of the new Cloud Foundry, and it just resonated with people. Actually.
Yeah, naturally.
So it's kind of, which then caused me to talk about it more.
Good. It was great. And then
it was this spiral.
Well, so you wrote a book, one of my all-time favorite books, which is the Microservices Patterns book. A lot of which you document, like our friend Gregor on your website, right? Gregor, he's got a book about patterns, but you can find a lot of that just for free on the website. But
no, you have to buy the book.
Sure, yeah, no, the book is better.
Really, you should hire me for training or consulting, because that is 100x better than any.
Oh, that is. It's true.
Website, yeah.
Right. So the book is I really didn't know what to expect. You know, I when I started to read the book, I thought, well, you know, like it's too new. But you did a great job. That book is thick, and it took it feels like it took you a fairly good chunk of time to write it, because it just I can only imagine why. The field is changing so much. You know, there's always this new stuff, and you're always on the cutting edge there.
Where the book is in my office.
My book, I've written a book or two, and they're definitely not anywhere near where I work, because first of all, do you go back and read your own stuff? If only for reference. I suppose I might do that once or twice, but
you know, sometimes, and then I'm surprised because I learn things. You know, like you can only get so much in your head, right? It gets paid out, and it's like, oh, I talked about this.
Yeah.
So, yeah.
That's like when I find my own answer on Stack Overflow. I Google something, I'm like, how do I solve this? I'm like, oh, I solved this like 5 years ago. Never mind, just use that. Yeah.
Yeah.
Okay.
Fascinating. I mean, you write a book or you write anything at a particular point in time, and then the contents of your brain somehow evolve away from that, right? Or it gets paged, in a sense, it gets paged out.
Right. For me, I always thought I would just accumulate more, but it turns out, like you said, you've only got so much working RAM, and it has to change. You know, the things you keep there will change with the tide. And these days, I think people are there's certainly, I think microservices is a prevailing architecture for good reason. I think it makes a lot of sense, and it's not just about the code, right? As hopefully this discussion has illuminated that there's so much more to microservices than just the lines of code you write. I'm hoping that will be Spring, obviously, but I would never say it has to be about. There's just so much more. It's not just Spring Boot. Oh, that hurts to say it though. I don't like saying that.
No, it's funny, right? Like on the one hand, when I'm wearing my pure microservices hat,
Right.
I'm trying to talk about concepts in an architecturally, in a language sort of neutral fashion, right?
Yeah.
Because the architecture just applies to, well, basically every language.
Yeah.
But I think I first started using Spring back in 2004.
Yeah.
Right. When I learned about learning about Spring at the server-side Java Symposium and talking,
That's,
so I think from Rod Johnson, right?
yeah.
Blew my mind. Actually, along with like Hibernate from Gavin Newsom, not Gavin
Matt
Newsom,
Newsom.
Gavin, the other Gavin.
Gavin's our governor here in California, the fair state of California.
Yeah, incomparable.
Yeah.
Yeah, and because at the time I was using EJB, right? Which, if you don't know what that is a good thing.
Yeah.
If you ever used it, you know what I'm talking about, right? And it just blew my mind that there were
1.0 and 1.1 and 2.
Yeah.
3 is better. Yeah.
Yeah, I guess there's newer stuff. Honestly, but I just learned about the Spring conference or Spring from that event, went back home to my team and said, okay, chaps, people, we're migrating from EJBs to Spring and Hibernate.
Yeah.
And really just sort of haven't looked back. And it's just remarkable how Spring has evolved while in a way remaining like the core concepts is still sort of unchanged in a sense, but it's evolved and it's still relevant, right?
Yeah. Well, never. Yeah, and I think it's because it serves the zeitgeist, and so when microservices and cloud native architecture started becoming more in vogue, it was sort of a natural thing for Spring to accommodate those use cases, and it just seems to. But and I think success is not just a matter of what you've got in class path; it's about how you wield Spring, to build a kind of architecture that makes sense in today's world. So obviously you could carry on building microservices, monoliths, using the old Spring from 2004 today. But again, you're missing out. There's a lot of opportunities there that'll make you feel successful. And I think today, 2023, we're already in August. We've got 4 months left in this turkey. I think the last 4 months are going to be the most exciting yet for Java developers, perhaps ever. We've got Project Loom. What are your thoughts on that as a Java champion?
It is awesome. No.
Yeah.
No, it's very funny this whole kind of the sort of the evolution of threads on the JVM, right? It's almost like on full circle, because I think in the beginning Java threads were actually lighter weight, and then they went to native threads, and now they sort of moved back. And to be honest, I'm very excited about it because that it's funny because you wrote a book on reactive stuff.
And you've done talks on it.
And I've, done talks about how great it was. Yeah. But in reality, just sort of thread-based programming is really simple, right? And reactive stuff is just kind of, it's like, you're moving outside of the language into frameworks that are just more complex.
Sure. Right? I would argue that thread-based programming is very simple, but the results are broken, which is the problem, right? They're deceptively simple, but incorrect. Like you can hurt yourself easily.
Oh yeah, well, it's I guess. Well, no, maybe what it is, it's like, well, I need to do things concurrently. So you are in you're sort of in a problem space that has inherent complexities, right?
Yeah.
Right. But But in a way, having multiple threads, say, I think is a simpler model than reactive, right?
No, I agree. I just think it's a simpler model to get the wrong result. To get the right result is much more complicated with threads than it is with reactive. Is I guess what I'm trying to say.
I don't know.
So,
I like just being able to go back to the basics of having a language where, you can do things sequentially in a normal way, right? A colon, B colon.
Yes, please.
As opposed to mapping and flat mapping and blah, 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 right? And I was thinking about this earlier. I feel like, on the one hand, I'm sort of a fan of sort of more functional type stuff. But then I feel like, if you try and solve a problem with monads, you kind of now have two problems.
Regular expressions.
Well, yeah. So
what I love about this is that they avoided the striped function problem, the async await or suspends of the world. In Loom sidesteps all of that, right? So you don't have to.
Yeah, well, some of those languages, they just like, why? It's like there's a disconnect. Once again, there's almost like this weird disconnect between the code that the language and the code that you need to write.
Right.
Because once again, A colon, B colon, C colon is way simpler than sort of any sort of functional thing.
You mean semicolon, but I understand.
Semicolon, yes.
Yeah. This is a great comment there, Crystal friend.
Oh.
Can you talk about the service chassis pattern first, and then let's see what he says.
Oh yeah. Oh, there's a couple of related patterns, which I guess since my book came out, actually maybe there's two patterns, right? Like one of them is service template. So it's like, how do you quickly get started with a new service? And well, one option is to go to start.spring.io, which I know is Josh's second favorite place.
Absolutely.
Right. I have heard you say that so many times.
Sorry.
But there's an alternative. As good as start.spring.io is, Josh's second favorite place on the web, is the concept of a service template, right? So that is it's basically a GitHub repo, or that's one way of packaging it. You can just copy it, and you have a skeleton service that's got, that's just sort of ready to build upon.
They even call them. They even have GitHub templates now, which are when you deploy them, they actually just clone themselves and they fork themselves basically.
Oh yeah, there's sort of some there's technology and stuff right around that, but it's like, here's a skeleton application or service that you can just clone, delete the sample business logic out of, and add in your own, and it's taking care of all of the plumbing. It's it's configured the right set of dependencies. It's got the right Gradle build plugins, and it's also got the right, say, deployment pipeline configuration, right? Like a GitHub Actions workflow setup, or Circle CI workflow setup, right? So you can just hit the ground running. So that's like, to me, that's a must-have, right?
Yeah.
But then the problem with that is that you get it's basically copy and paste programming. And so things can kind of drift, right? And then if you need to make changes, you need to make changes in all of the copies of the template. Yeah. So the next pattern that solves that is the microservice chassis pattern. So that contains all of the common stuff, which can be like reusable chunks of Java configuration. It can also be Gradle plugins. It could also be some template sort of, actually like even predefined GitHub actions or Circle CI orbs. And so all of that common stuff is moved out of the template into that, and the template is built on the chassis.
Yeah.
Then your service is a clone from the template. And then hopefully if things change, you just need to upgrade your service to use a newer version of the chassis, fingers crossed, and you automatically get all of the good stuff.
Wait, so the chassis brings code snippets and all that?
Well, yeah, maybe there's some, like for instance.
Like how do you version a bunch of assorted files? Is that just a...
Let's just say that you have a rule in your company that all REST APIs need to be secured with JWT, right? I mean, that's an example, right? So somewhere there's so in your service you need an act configuration class that sets that up, right? So you could have that in the chassis. So you just write it once and you import or you auto config. So it's like it's the custom stuff that's relevant to your, well, I guess you could say organization and your application.
Is this, am I mistaken in saying that this is a pattern well served by Spring Boot's auto configuration mechanism?
Yeah. I mean, it is, firstly, it's obviously a very generic concept, but once again, Spring Boot has some awesome stuff, like auto config and so on, that just help. Yeah,
that's cool. That's for things you can package up in a library or something. But would the service chassis include things like a Terraform or my GitHub Action or whatever? Like, how would you version number that?
Actually, yeah. So let's say the service template will have GitHub Actions workflow in there, right? That does the usual steps, right? Up to and including, say, publishing a Docker image to a repo and then publishing a new version of the Helm chart that references said Docker image, right? The chassis could also, I think the scope of the chassis can include Gradle plugins that for helping with the build. But then arguably the chassis could also part of the chassis or things could also be your own custom GitHub actions.
Right.
Circle CI orbs, right? So they're obviously not in the library itself, but they're floating around wherever they need to float so that the pipeline that's in the chassis, in the service template references them in whatever way makes sense.
So there's not one big version for the entire code base, but it's simple enough to increment a number somewhere in the GitHub action definition for the plugins or in Gradle.
Yeah.
Okay. Yeah. So those are static, but the thing you're upgrading, there's not a lot of code becoming stale in your project proper. You just pointed to the new version of an artifact floating around, like you say, somewhere. That's a really cool pattern. Really cool.
So I mean, I think like maybe when I wrote my book, I might have made. I can't remember what I wrote. But at one point, I know that I thought, we just have Spring Boot, Spring Cloud, and they basically are the chassis. But then somewhere along the line, I realized, no, those are the building blocks for the chassis, and then you have stuff that wires them together in the right way. Plus all these sort of like Gradle plugins and possibly deployment pipeline plugins as well. and then collectively that forms like the chassis.
I see. Okay, so it's all the extensions that your organization puts forth in a reusable way to augment a stock standard start.spring.io project.
Yeah.
Okay. Cool.
Which is Josh's second best
It
on the internet.
It's true. So are you on the internet? And do you want to be found? And if so, where can people find you? Have you set up your Threads account yet?
What's that?
Are you on Blue Sky? What about Mastodon?
Yeah. Actually, if you go to, if you like on Twitter, right? That links to an About Me page, and then that About page has links to all of these, the newfangled social media things.
Yeah. Oh, we have a great question here. If you feel like I'm gonna put this here, and we'll just let that simmer, let it stew, let people take a note of that. And in the meantime, while people are jotting that Twitter account down, you should be following him. I certainly do. We have a great question. What are your thoughts on deploying an app, a set of microservices, into multi-clouds, or in a multi-cloud environment, I guess?
Yeah.
Terrible last question.
No, it's a really interesting one. Like, I feel like, these clouds, public clouds, Amazon, Azure, there's a tremendous amount of technical depth to them.
Yeah.
And I think it's challenging to be a multi-cloud, cloud native person, right?
Yeah.
Or cloud native, because there's so much to learn,
Right.
which always seems to begin with having your own access key and secret on AWS.
Right.
So there's that. And so I feel like people need to go all in on one, or individuals for sure need to go all in on one cloud. And for the most part, I feel like organizations should just go all in on the said cloud as well.
Yeah.
So I'm sort of, and then at the same time, I'm kind of skeptical about a lot of this multi-cloud stuff. I feel like that has sort of been promoted by vendors who are desperately trying to sell you multi-cloud solutions, even though you don't necessarily need them. No offense to anyone. But then on the other hand, there could be use cases for multi-cloud, like, right now Google has some feature that's better than AWS, right? And so there is genuine value in having stuff running, some of it on AWS and some of it here, right? Though, of course, there's that whole data gravity concept about the cost of communication between clouds. And
right. That's Dave McCrory's old thing.
Which I think is, it's just reflecting the laws of physics, right?
Yeah.
And it's such a great, data gravity is such a great concept.
Really is. So I think that last point, it's not that you're redundantly deploying everything to every cloud. It's that you're all in for certain workloads on more than one cloud, right? So
but there's a cost to that, right?
Sure.
You need to have people who are experts in more than one cloud, and having people who are experts in just one, I think is tough enough. So you should be very cautious.
Sure.
About it. And actually Gregor Holpe, I think he's got a cloud strategy book, right? Which talks about this issue in a lot of detail.
Wait, I gotta get him on the show. He's a character. I have we could tell stories. He's great.
He's a great guy. He is so smart.
So smart.
Really is.
Yeah. Like you, by the way. So thank you for hanging out today. I know that I have been harassing you for nigh on like 4 years to get you on the show, and it's just been really. Just so
we did one a few months ago.
You what?
We did one a few months ago, didn't we?
Did we?
Yeah.
Oh. Well,
No, but this has been a pleasure. It was such an unexpected activity this afternoon.
It was good for me. I've been fighting jet lag, and so this has been really actually great. Otherwise, I would have just curled up in bed. And
I know. That's the thing. The only reason you interviewed me is you wanted someone to keep you awake, right?
Yeah, well, and to make my brain feel happy to be awake. Otherwise, I'm just going to bed. Thank you so much. Everybody here is grateful. Obviously, this is late in the afternoon. A lot of times I do these streams in the morning, but jet lag again. Everything's all off kilter, off balance.
Yeah,
and I really appreciate it.
No, this is a pleasure. Thank you for pinging me 2 hours ago or whenever it was.
I appreciate it. When's the next? I mean, I don't know. You're still running the Java user group there?
No, it's I've let it lapse, unfortunately. I mean, I encourage everyone to go check out the San Francisco Java users group because they're super active.
It has become more and more valuable. Obviously the one. So you used to run. You don't have to mention it if you don't want to, but anyway, it's not far from here. But it is. Well, it serves
a Java users group. I mean, to reality, I probably just someone needs to nudge me into actually doing something.
Well, if you decide to throw an event, I'd love to come speak at some point. Is all I guess I was trying to say.
Yeah.
There's great food over. It's not that far. It's like 15 minutes drive from here to your doorstep or whatever. Yeah. It's just very, very just very. Now that people are starting to do in-person events and stuff, I think Java user groups. I need to put more. I need to invest more into them.
Yeah.
Okay, my friend. Thank you. Have a great day.
Yeah, you too. Thanks, everyone.
Bye.